Now let's look at this figure 14-10 from Stallcup's Electrical Design Book, Volume 2. And notice that we have the overcurrent device here, and it's a branch circuit routed out. And from this branch circuit, we're tapping to a 10 kW cooktop, a 9 kW oven, and an 8 kW oven. And our taps are in accordance with 240.21a. The overcurrent device is sized from 240.4b. And then we have our junction boxes where we splice in and make our taps in 314.16a2. And in course sizing the branch circuit, we go to table 220.55 and we reference the note 4 below the table. Now with this information given, let's look at the boxed in information and look at the question. What size tap is required for the 10 kW cooktop? So we would take the current is equal to, say, 10 kW times 1,000 to get rid of the K, and it'd be 10,000 divided by the voltage, 240 volt, and we'd come up with 41.7. Then we'd reference 334.80 and table 310.16, and we'd see that 41.7 amp with no derating, with no correction factors, would be approximately a number 8 conductor required to take care of 41.7 amp. So the question is answered in this step 2, and then we have the solution. We have 2 AWG with ground, non-metallic sheath cable. Depending what part of the country you're from, that could be non-metallic sheath cable could be called rope or Romex, and that's the size that would be required. And then note, size the other taps using the same procedure. And now we see just how a branch circuit could be tapped, as you see, for a cooktop and 2 ovens. And that's what this figure 14-10 is illustrating to the user of the NEC.